All right, so it's a code loader for Ruby, and these are the main features that the library provides. Uh, it is able to autoload code. It is able to either load code, reload also, like we do in Rails, and it is designed to run in gems and in applications. So, for instance, if you write Rails applications, there's something with the sound working, good. So, if you write a Rails application, you know you can autoload code. You have been able to do that always, but gems, well, there was some solution to do something similar, but in general, gems do not autoload code the same way Rails applications do. That's the thing. So with Zeitwerk, that is possible. You can write your gems, or any. It doesn't need to be technically a gem. Any Ruby project can have Zeitwerk as a dependency and autoload code the same way you do in Ruby on Rails. All right. First of all, let me show you how do you use this. Okay. First, there's a convention, which is that file names have to match constant names. Okay, we do already this in Rails, and if you are in a pure Ruby project, let's say, that's the convention. The project has to follow that structure, which is a very conventional structure anyway. So, for instance, top-level classes and modules. So, if you have user.ruby, it should define user. No mystery, right? If you have user profile, it should define user profile in camel case. So we are following the normal conventions in Ruby, which are that you have snake case in the file system and camel case in the name of classes and modules. HTML parser should define HTML parser, but look at these lowercase letters. If that's fine for you, done. It works automatically. If you prefer that these ones are uppercase, there's a solution for that, because you can configure a custom inflector that is able to, configure exceptions to this basic rule, right? Then the file paths match constant paths. In the case of directories should match to namespaces. Okay. In this case, we have something that I call explicit namespace, which is that hotel.ruby defines hotel, and then there's something below hotel pricing, okay, and that should live here in a subdirectory. So sorry, in a directory called hotel pricing.ruby, okay, as we do in Rails. I call this explicit because the hotel namespace is explicitly defined in hotel.ruby. There exists a hotel.ruby that defines the class in this case. But sometimes we do not define all the namespaces with an explicit file. For instance, in Rails, you can define something below an admin directory, and you do not need to define admin.rb with a module definition. It just works. How it works? Because Rails, if there is not explicit definition, is going to define a dummy module for you with that name. Okay, it does that automatically, and Zeitwerk does that as well. Okay, so we have the project structure. How do we use Zeitwerk? Very easy. You instantiate a loader. You tell to the loader which are the root directories of your project. For instance, in a gem, normally this is going to be lib. Everything below lib has the standard structure done. So one root directory. In a Rails application is going to be app models, app controllers. There are several root directories. Okay. In Rails, you are not going to need to do this, because the Rails 6 has this integrated, and the integration does this for you, all right? But this is like the bare usage of the gem. Once you have configured the root directories, then you run setup. And setup does some minimal, starting thing that we are going to see later. In the case of gems, indeed, since normally you have one lib directory, which is the only root that you have, and also there's a convention in gems, version.rb normally defines the constant version, everything in uppercase. So it does some, small, convenient setup for gem-like loaders, and it's enough to do this. But you can also do the other thing in gems. This is not necessary. It's just a shortcut, all right? Okay, then the basic API. There's more API, and the README has it all. But the basic API is this. You set up the loader. Then you can auto-load. You can reload if you want, although normally only a service is going to reload. So if a service depends on 5 gems, and the gems use Zeitwerk, those gems use Zeitwerk, normally those gems are not going to reload, normally, right? And if you are developing a gem, normally there's no service running. So you write the gem, and maybe you run the test suite, but that doesn't involve reloading. So reloading basically is thought for services, Rails application, and other web applications written in other web frameworks, and in general, anything that has a daemon or something that is running, okay? Eager loading is also provided, and this is convenient for production. By default, Rails applications, for instance, eager load the code in production. When you ship a gem, you could say, just eager load my code, right? Eager loading needs auto-loading. This is something that sometimes we do not realize. But in order to, eager loading is not just required recursively. That wouldn't work in general, because files, if you evaluate a file, it could be the case that at the top level, or a class level, or in the execution path of that evaluation, you are referring to other constants. So in order to load in order, you should need to have like a dependency graph of everything that is used everywhere, and we do not have that. So you cannot just recursively load. You have to have autoload set in order to be able to eager load a generic code base, at least. All right? So thanks to having autoload, we can eager load any project that follows the conventions in the file structure, which is the only thing that we need. Finally, there's a method. Zeitwerk registers all the instances that are created, and then you have API to eager load them all. That's convenient, for instance, in production. In a Rails application, you want to eager load as much as possible on boot, okay? Then, no matter whether the dependencies eager loaded or not, you are able to say eager load the code of the application, assuming that is using Zeitwerk, and also eager load the code of any other gem that I depend on that is using Zeitwerk. So in general, you are going to boot the main process with as much as possible things loaded, and this is in general convenient, and you're going to load things earlier, copy and write, memory benefits, and that kind of thing, okay? Again, in a Rails application, you do not need to do this. Rails does this, okay? The integration does this. Okay, which is the motivation behind Zeitwerk? The initial motivation was the last one, improve Rails autoloading. Why? Because if you are a Rails programmer, you know that autoloading in Rails has some edge cases, some gotchas. It is practical. It has been used for many years, since the beginning, indeed. But it has some gotchas. It doesn't follow Ruby semantics, and that's the main thing that doesn't quite square. But it was the best that we had, okay? So I wanted to improve Rails autoloading, but once I started working on that, I realized that this could be generalized and address another pain point of me, at least, which is that writing requires manually is brittle in Ruby projects. Okay, in Rails, you do not feel this that much maybe, because precisely you do not write requires in Rails. Everything is autoloaded. That's the magic. Okay, that's the cool thing. But if you have written any non-trivial Ruby project, you know that this is brittle. Where you have to write requires is brittle. Dryness in generic Ruby projects. Well, that's also a perception of mine. If I have a user.rb file and I need to tell Ruby require user, I have a sense of duplication. Okay, so if all my files correspond to constants in an ordered way, I'm always repeating myself, because everything is ordered. Okay, everything has a one-to-one relationship between files and constants. So when I need a constant and I need to put again in a snake case the require for the constant to be available in a file, I have a feeling of lack of dryness. I could solve this, remove this with a convention. Okay, a convention which is pretty natural otherwise. That's a pet peeve of mine. Okay, maybe for other people it's not a problem. You write requires and fine, but this is something that I wanted to solve for myself. Let's talk about requires for a moment. So, for instance, let's say we have a locatable, I believe this is pronounced, module that I don't know, for coordinates or something, you know, and you have a class with an airplane that includes this module. In a pure Ruby project, this shouldn't work. You are going to find an initialized constant locatable. Why? Because you have to do a require. You have to remember that you have to put a require. Okay, require is going to load this file if it was not already loaded, and this file is assumed that defines the locatable module. All right, so it's going to be available in this file. All right, but the problem is that require has a global side effect. So if you require locatable, this is not a compilation unit, let's say. This locatable is from this point on available in the virtual machine everywhere. It's just a global thing. So it has a global side effect. What happens that this without the require could work. If someone in your code path before you reach this point loaded the module, is going to be available. And you do not notice. You notice when in production you hit a different code path and you have a constant missing. Okay? It's super brittle. You have to be super disciplined, remembering everywhere, you know, that every constant that you use should have the corresponding require. Other people, instead of putting requires, you know, selectively in its file, decide to put them all in the main file, the main entry point. This is nano C, which is a static site generator. Okay. Nano C decided, instead of putting all the requires in every single place, well, you know what? I'm going to conceptually eager load everything. This is the main file, the main entry file of the gem. Conceptually eager load everything, and everything is available everywhere. Of course, you can see that this is not this has a cost. No, when you create a new file, you have to remember to go here, and also there has to be an order here. You cannot put it anywhere. You have to respect the dependencies between these files. So this is doable, but also has a cost in that sense. So just delete all this shit. Okay. So this is nano C is using Zeitwerk. Just delete everything, instantiate Zeitwerk, done. I love this patch. When I saw it, it was like, yes, that's it. That's the thing. So that's the idea. You can streamline your programming. You just forget about this problem. Just name the constants according to the file names. Instantiate a loader, set up, done. Your classes and modules are available everywhere. That's the thing. Okay. Autoloading and loading in general, I tend lately to speak about classes, modules, and namespaces, but in reality, technically, this is all about constants, okay? And knowing how it works regarding constants is key to understand how this works, and when you have a problem, to understand where the problem comes from. So let me just give you a quick refresher about constants in Ruby to have more context about the problem. So, you know, constants in Ruby, one identifier that starts in uppercase letter is a constant, which is like a variable, but it is not supposed to change. You know, constant, pretty common concept, normally pretty trivial concept in any programming language, but in Ruby it's not trivial at all. It's not trivial at all because it is vinculated with classes and modules in a way that so classes, modules are objects, they are an independent entity, and constants are storage, but there's like a coupling between the two of them, because here we have a constant assignment as well. It is not obvious, but it is. So this is clearly a constant assignment, right? This is also a constant assignment. It is the same thing as writing this. So C here is a constant. Think variable is storage. There's no syntax for classes or modules in Ruby, okay? So here we had 1 assigned to X. What we have here is a class object assigned to C. So C just stores in one slide, is storing a 1. In this slide, it's storing a class object. It's a different kind of object, but it's exactly the same thing. From this point on, C is a constant. And C can be removed. The class object can be stored in another place. They are totally independent entities. For instance, this is super key. When you see this code, in our day-to-day, we see here the user class, the date class, right? But if we stop and think for a moment, what happens here is that user is an expression. User is a constant. The user constant evaluates to a class object, and that object responds to the new method. The return value of this method is stored in this variable. Same here. Date is a constant. Evaluates to a class object that responds to today. The return value of this is we store it in a variable. So when you see this, in the day-to-day, we think classes, okay? But in reality, technically, this is just a constant that evaluates to something. We could have this class object stored in a variable. We could have this class object stored in a different constant, okay? They are totally orthogonal concepts. Constants belong to modules, like physically, like top-level constants belong to object. And if you have a namespace, the constants within that namespace belong to the class or module that defines the namespace. For instance, here we have class hotel. That one is going to belong to object. Then we define within hotel module pricing. The pricing constant is going to be stored in the module that is stored in the hotel constant. That's all the thing, all right? So this thing is going to belong. The thing has many. Module has many constants, and it's like you can imagine that internally you have like a symbol table or a hash table where the name of the constant maps to the value that is stored in that constant. And this map or this symbol table is stored in the module. And every module has its own symbol table like that. So this pricing constant that belongs to hotel has nothing to do with a hypothetical pricing constant that is at top level. If we have the same name, they are totally different objects. Pricing at the top level, it belongs to the system table of object, let's say, while this one belongs to the system table of hotel. There's nothing, they have no relationship. We have an alternative syntax to define that like this. This is the same thing, defining a pricing constant within the module that is stored within the hotel constant. Okay. We are going to see how constants are resolved very quickly. To introduce that, let me just explain very quickly what is nesting, which is important for that resolution algorithm. Nesting, intuitively, if you see, so I'm not going to give the full technical definition, but for the day-to-day, it is enough to understand that when you use the class and the module keywords like this, and you put things nested, like nesting namespaces, when you arrive to a point, the classes and modules that are in each of these levels become part of the nesting like this. So at this point, the nesting is hotel pricing, which is this one, and hotel, which is this one. Okay? Object, which is at the top level, does not belong to the nesting. Here, this is different. We only have a module keyword here, right? Or there's only one level of nesting. This is very important because the way things are resolved is different here. Why? Because the nesting here has only one module, this one. Here we have two, because we have two levels. But here, it doesn't matter that the constant has like two segments. It doesn't matter at all. You have one level of nesting, that's it. That's the nesting, only one module. Okay? Here we see the name of the module printed. But these things are objects, like the module object, the module or the class object, you know? Okay. So if you see a listing, and you wonder which is the nesting at some point, just go outwards, this indentation, and that's what conforms the nesting. The other one is the ancestors. The ancestors, basically, of a class or a module is the chain that you have upwards with include modules, superclasses if you are working with a class, and that's like linear, all right? So for instance, ancestors of a string itself, so this guy is belongs to the ancestors, and if this had prepended a module, it could go indeed before the same object. Comparable, which is a module, right? Object, these are the ancestors. For instance, this is used when you want to resolve a method, okay? This is going upwards. So if the method is not defined here, you look here. Otherwise, you look here. This is the ancestor chain. Okay, so we are ready to quickly revise the algorithms for constants. There are two cases. There are a few more eights, but these are the main ones. When we have a relative constant, like for instance, when you say string in the middle of a listing, all right? Ruby does this. First, checks the nesting. That means that the nesting is conformed by classes or modules, right? So Ruby checks the first element of the nesting. The constant belongs here. Let's imagine the answer is no. It checks the next in the nesting. Does the constant belong to this class or module? Let's imagine the answer is no. It goes to the nesting outwards. If the constant is not found in any of these class or modules, then it goes the ancestor chain upwards. So we first go in diagonal nesting than in vertical ancestors. There's a technicality here that is that if the inner module in the nesting is a module, then it also checks object. All right, and that's why if you refer to a string within any place in a module, you find a string, even if a string does not belong to anyone in the nesting, and it does not belong to the ancestors of modules, because object is not an ancestor of modules. So you need this special rule in order to find top-level constants. Finally, if you do not find the constant in any of these places, there's a callback, call it const missing, that is called, and it says const missing, I have not found this constant. The default implementation of const missing is the one that raises name error, but you can override that. Then if you have a qualified constant like digest MD5, in digest MD5 we have two constants here. Digest is a constant, and this one is like it is written here. This one is relative and could be resolved with the previous algorithm. MD5 is a constant that is qualified with colon. So this one has a different algorithm, which is much simpler. You just check the ancestors of this guy up, and that's it. Const missing as a fallback. Okay. There's a technicality that object is skipped, but that's enough. All right. Basically, nesting. So relative is nesting ancestors, const missing, and if it is qualified, you do not check the nesting at all, just ancestors and const missing. Basically, that's the idea. Okay, so we are ready to understand how Rails autoloads, as a summary at least. In Rails we have something that we call the autoload paths that represent the root directories, the root namespace object. Okay, we have this, and in autoload paths by default, anything that is a subdirectory of app is there. So app models is there, app controllers, app helpers, whatever. Okay, and Rails defines a const missing that implements the autoloading, or is the entry point to the autoloading. So what happens in Rails? If you have users controller, and users controller defines or uses the user constant, like in an action you say user find params ID. You know, you are using the user constant. What happens if the user class is not loaded? This algorithm is going to go to const missing because the user constant is not known. And const missing is going to say, okay, I am user's controller, and I am told that user, a string, the name, is missing. Then Rails goes and walks the autoload paths looking for a user.rb. If it finds a user.rb, evaluates the file with load by default in development mode, and as a side effect of that, the user constant, if everything is okay, is going to be loaded, and then you continue the evaluation of the code. But this technique has limitations, and that is why we do not have Ruby semantics in Rails, fully Ruby semantics. For instance, the nesting is unknown. All the information that you have is, I am user's controller, and someone wanted to evaluate the user constant here. Which is the nesting at that point? No clue, because Ruby doesn't tell you. The callback, the API of the callback, just receives self and the name of the missing constant. That's all the information you have. So we saw that the nesting is part of the resolution algorithm, and we do not have it. So that's a fundamental limitation of the technique that Rails has used since forever. We do not know if the constant missing was relative or qualified. And in general, there's some special rule, but in general, you have to assume that Rails, since it doesn't have that information, is going to assume that it is relative. Okay, this is going to assume that. Then const missing is the last step. That is important. For instance, let's say you have, like in the example before, a class hotel and includes a module called pricing. And your intention is to use the hotel slash pricing, that's module, okay? But what happens if we have a top level constant pricing that is top level? It has nothing to do with the constant that you want to use, but it is defined. What happens is that since const missing is the last step, Ruby is going to find, in this algorithm, is going to find the top level one. I got one, here it is. And it is not the one that you want. You would like to autoload the one in hotel, which is the most specific one. But since Ruby is able to resolve pricing to some constant, that's it. It's not going to call const missing. So const missing being the last step is also a source of some gotchas. Finally, it's not thread safe. So in Rails, Rails has been thread safe for a while, but many years already. But in development mode, for instance, for autoloading, Rails sets some locks and some stuff to be able to be thread safe. In production mode, normally that's not an issue because you eager load everything, so there's no going to be autoloading normally in production. Okay. Okay, let's keep this one. No, this is how Rails works, and these are the limitations of the technique. How does Zeitwerk work? Because Zeitwerk solves that. So Zeitwerk relies on module autoload. Module autoload, that's something that comes with Ruby, all right? Say you have this module active record, and you say autoload base and a string. This means that we are defining active record. Then we are saying, if you in any place want to access active record column base, Ruby is going to intercept that and is going to go and require this file for you. So this is a way, and this is in the Rails code base that's used a lot. It is a way to defer loading the file until you use it. Okay? So that's built in the virtual machine. And when I explain it, the algorithms for constant resolution, I skipped one step, which is that every time Ruby checks in a class or module if the constant that is resolving, if the constant belongs to that class or module, actually it says, let's say, conceptually, do you have it in the symbol table? If the answer is not, then still there's a second question. Do you have an autoload for it? And if you have an autoload for it, it's going to execute the autoload. So that's built in the virtual machine, and that matches semantics. Why? Because it's injected in the actual algorithm. So it is going to find the constant, the one that you want, because in every step is doing these checks for autoload. But all right, yeah. So the same idea. You have autoload paths, and the thing is that when we run setup, when we instantiate the loader and put setup, the loader is going to walk one level of those paths, and it's going to say, okay, you have user.rb. I am going to set an autoload for the user constant that if used is going to go and load user.rb. That's the basic idea is this. Then from here to the implementation, there's some stuff to resolve. But that's the basic idea, and that's amazing. And because if this is possible, this is using API and logic that is built in the virtual machine. And why it works? Because the merit is from the virtual machine. We are just leveraging, this contract. So you walk the root directories and set autoloads for every one of the constants that should match the file names that you find. That's for the top level. There are some technical difficulties, nevertheless, with this approach. Module autoload is something that I have had in mind for many years, because when I have studied this topic, and it was like, oh man, if we could use module autoload, all these problems would disappear. But there were some technical difficulties. Some you could work around, some you have been able to work around later. For instance, module autoload uses require internally. That does not allow, in principle, to reload code, because Rails is able to reload code because it does not use require in development mode by default. It uses load. Load is something that is provided by Ruby. It's not very common, but load basically is execute this file no matter if you already executed this file. It's just go and evaluate this file, load. All right? So in development mode, Rails uses load. When you want to reload, if you say load user, it's going to load again user. If you instead of load use it require to load user, because in the end you have to load the file, right? So if you did require user, the second time in reloading that you use require would say this is already load, nothing to do, and you could not reload. So in principle, this is a problem, okay? But Zeitwerk is published, so we have solved everything that's here, right? Let's keep it just a little bit of mystery. All right, there's no API to remove autoload, so you can set an autoload, but there's no API to remove an autoload, right? And this is important because if you are reloading, for instance, and you had user.rb in some place, and then you want to reload and you remove that file, and you have a user.rb in another place with different contents, you would like to reload to autoload that other one. But if you do not remove the autoload, it is going to look for the previous file that couldn't be correct. Okay, so you have to be able to remove autoloads. Also, it does not support namespaces in the sense that you cannot say in object autoload admin : user. You cannot say that. You are only able to set an autoload for one level. So in object user, and then when you load admin, you are going to be able to put an autoload for admin for the children of admin, but you cannot pass qualified names to autoload, only one level. The other one is a chicken and egg problem, that this was the most difficult one for me, and I am going to explain that one later. All right, let's see how we work around those difficulties. So as we know, if you require user and then require user again, the first one is going to load, the second one is going to do nothing because it is already loaded. That's the contract of require, right? Okay, how does require know that the file was already loaded? Because it has a collection of the files that have been already loaded, call it loaded features. Okay, so it goes to loaded features. Well, it has to resolve this, right? You get a full path, whatever, and you go to load features and see if the file belongs to load features. If it belongs, false. If it does not belong, you load and true. All right? So that collection is mutable. If we modify the collection, you are able to reload again. Okay? This is an old trick that in Perl land it's been known for forever. In Perl you hack everything. So yeah, first one solved. Okay, we mutate loaded features. It has been a principle of the development of the library to use as less hacks as possible. So the library, on purpose, relies as much as possible on standard API from Ruby. The hacks are super, super minimal, super justified, and I believe not rare. Like this level of hacking, right? Well, and this works. This is, I mean, I don't know if there's documentation that says that you can mutate this thing, but it could be very strange that this changes. So just a little hack, okay? Remove the file. You are going to be able to require again, because there's no way to say to autoload that it should use load. There's no API for doing that. That's written in Ruby, and there's no way to around that. So this is the workaround. Removing autoloads. Well, there's no API, but if you remove the constant, even if the constant is not properly loaded, that removes out. In fact, that removes the autoload. So this is enough, okay? And indeed, something that I have learned writing this library is that for Ruby, an autoload, a constant that has an autoload, more or less for Ruby is as if the constant was defined. So all the API works. All right. Now, we said you cannot put an autoload for a constant path. You have to go one step at a time. So let's imagine that we have an admin directory. What do we do? Okay, so Zeitwerk, when it does the work, it says, okay, we have a directory here, and there's no admin.rb, only a subdirectory. So what we do, this is also a little hack, is we set an autoload for the directory. This is undefined. I mean, you can put autoloads for files, but for directories, but it works. What happens that when admin is referenced, autoload is going to require this file. And then we have super, super thin wrapper around kernel require that says, hey, this is a directory that I managed. So we intercept that call. We intercept that call. In this case, we define a dummy module like Rails does. And then Zeitwerk goes to this directory or directories, because admin could be defined in several directories, and does one level more and sets autoload to this admin module that it has been just instantiated. And this is the tricky one. And indeed, I did not solve this one. I copied the solution from another gem. All right. The thing here is, you have this is called, I call this an explicit namespace in the sense that the hotel class defines a namespace, and it has a file that defines this class. All right. What happens here is a chicken and egg problem, because you cannot evaluate this file because this pricing is not ready. For having to have this pricing ready, you should be able to have the hotel class in order to be able to put an autoload, but the hotel class is the thing that you want to have as a side effect of evaluating this file. You cannot go here either because you need hotel. So you cannot evaluate any of the two. They have a dependency between the two. All right. So to solve this, we set trace points on the class event. Trace point is an API, and there are several types of events that you can listen to. This is the one that is triggered when a class or module is created or reopened. All right? So basically, the idea is that we set a trace point to listen to class creations, and we register that we are interested precisely in hotel. What happens? The thing is that we are able that way with the trace point to be called precisely at this point, before the class body is being executed. We are called here. So since we are called here, the callback that we instantiate, this block is going to be executed, we are on time to go to the directory and set autoloads. So when we reach this line, the autoload is set. That was like, when I saw this was possible, it was like, okay, we have it. All right. So to finish the presentation, the integration with Rails 6, which is, I've tried to integrate this in a way that is as transparent as possible, as well integrated as possible. So in Rails 6 is going to be enabled by default. In Rails 6, now you have two ways to autoload, the classic way and the Zeitwerk way. So if you generate an application, a new application in Rails 6 is going to have this line in config application.rb, and load defaults 6.0 is the code that sets Zeitwerk as a default autoloader. If you do not have these defaults, but you are upgrading to Rails 6, you still can set it as well, but well, this is the default that way. This is API to be able to trace the activity of the autoloader. Sometimes if you want to troubleshoot something, this is very convenient. Just throw this in application.rb, and all the activity of the autoloaders is going to be logged in this case. So this accepts a lambda and accepts a logger object as well. Okay, if you pass a lambda, like this thing, this is a trick to get a callable here. It just calls the callable with a method with a message. If you set a logger, it uses the debug method of the logger. But this is super convenient, and you do not leave this permanently. Okay, so it's just you troubleshoot something, and then delete this line. That's it. Then it could be the case that you have to configure some inflection, because we are going in the opposite direction of the classic autoloader. So the classic autoloader, in const missing, you get the constant name, and given the constant name in camel case, you inflect and go to snake case and look at the file system. So, but Zeitwerk goes the other way around. Zeitwerk starts at the file system and says this file should define this constant. Okay, so underscore and camelize are not. This is not a bijection. Okay, you cannot. The one is not the inverse of the other one. In the common cases, they are, but if you start to use acronyms and that kind of thing, they are not the inverse of the other one. So, for instance, it could be the case that you have some HTML or some API, something, and maybe you have to say in the flexors, look, API is an acronym, HTML is an acronym, okay? To have it inflected like you want. You can also rename the class, and call it a day, and have HTML in lowercase, and that's it, But if you have some difference with respect to the previous autoloader, if you are upgrading an application, maybe you have to add something here. Yes?
Zeitwerk give me a helpful error message if my class name does not resemble the file name?
No, well, not really, because what happens is that the constant is not found, and that's it. The constant.
But in the moment Zeitwerk is reading the class, reading the file, it is not telling me the class name does not resemble the file name, so I don't get this error message in this moment.
Well, what is going to happen is that you are going to refer a constant for which there's no autoload. So Zeitwerk is not able to intercept that. And Ruby is going to say, I don't know this constant.
Okay.
So yeah, that's how it works. You say, HTML parser not found. Oh, I have an HTML parser. Then you have to realize that the inflection is different. And then there's also a way to opt out. So that's the default. But if you are, for instance, upgrading and you have work to do for whatever reason, you can still use classic this way, and this is going to be exactly the same thing that you had before Rails 6. Yeah, all right, so that's it. Thank you.
Okay, we have a microphone, so if someone would like to ask any question, just raise your hands.
Hi. For the last slide, is there a way to do it incrementally? Like I want to use Zeitwerk for this folder, and I want to opt out for the rest of it, so you can do like incremental migration when migrating to Rails 6?
No.
No. Okay.
No, you either, no.
Okay.
Classic or Zeitwerk, that's it.
Cool.
Any other question? Yeah, so I'll
Excellent.
read a question from the online viewers,
All right.
which is, could this autoloading approach be added as a language feature to Ruby itself?
Oh man, I would love that. So the problem is that the fundamental problem is that in Ruby there is no relationship between class and module names and file paths. It's flexible in that sense. This is the way Ruby is designed. There are other languages that do not work that way. For instance, in Java, the class files have very strict structure that matches the name of the class. And if you are willing to write the fully qualified name of a class, you do not need to do anything. It's available. As long as it is in the class path, it's available. In Erlang, the same thing. In Erlang, you just use modules. In Elixir, the same thing. You just use modules. You do not have this require anywhere. So why? Because since there's no option, your module name has to match the file name of the compiled file. There's no option. Then the language can rely on that and give you autoloading, because in the end, they are autoloading. All right? So since Ruby does not have this, we have require, and we have all this way of doing things, and this is why Zeitwerk requires the project structure. And I would absolutely love that Zeitwerk was not needed. I would absolutely love that Ruby does this, and it's something built in. But that's something that belongs to the Ruby core team, and I believe it's very unlikely because Ruby has been working with this contract since forever, and I don't think it would be reasonable to expect that this changes. But I would vote +1 to that.
Thank you. And the second question is, what would be the migration path for a Rails 5 app?
All right, the migration path. Good. So, in general, should work for the majority of classes or modules if you have followed it. So, the good thing is that we are using the same conventions that are used by Rails. So, since we are using the same conventions, the application is going to be ready. So the migration, there's not a lot to do. Things that you could consider. First, that maybe you need some inflections, like I explained it. That could be something. And another thing that sometimes happen is that you discover that your application was resolving a constant that shouldn't be resolved, because it's used in a place where Ruby should not find that constant, but because, as I said, classic autoloading assumes, in general, except for some special rule, that the nesting, that the name, the fully qualified name of the constant reflects the nesting, for instance. So sometimes the classic autoloading finds a constant that Ruby, I'm not going to say that it shouldn't find it, because classic works this way. These are the rules. So it finds the constant according to the logic of classic. Let's say that Ruby would not find that constant. So since Zeitwerk matches Ruby semantics, the constant is not going to be found. Okay, that's Somet's case, and I am going to document that in. There's going to be a guide for this, and also there's going to be an upgrade guide like Rails also always have. And in the upgrade guide, I am taking notes of some people that have done upgrades, and there are some super edge cases that I am going to document. But you know, apart from that, should be seamlessly, or I don't remember how to pronounce this. Should be transparent, let's say.
Thank you.
Yeah. Hello, Xavi.
Hey.
Are you planning to ask for some change in the Ruby API in order to avoid doing that hacks on Zeitwerk?
Well, there's one thing that maybe I try to open at least an issue or send a patch, which is that this is something that is needed inside the implementation. So basically, there's for instance API to say, does this module have this constant? That's const defined. Okay, you can say a string const defined something, and if it's defined, it's going to say true, otherwise false. Okay, you can pass to that a flag that says, please check also the ancestors. So basically, it could be if I write a string colon this constant is going to give me something. If you check the ancestors, that's it. But you can pass false as in that flag. That means I am only interested in knowing that if this constant belongs to this particular module exactly in the symbol table of this module. Do not check the ancestors. Okay. All right. Zeitwerk needs that also for autoload question mark. So there's a method autoload question mark that tells you if there is an autoload set for a constant, and we use that internally. So that method does not support that flag, and that method always checks the ancestors. And well, the logic of Zeitwerk needs an autoload question mark that that is able to ask for do you exactly this module has this autoload set? We need that. The API is not there. I am sure is doable because const defined has that logic. So I guess it's just not written. Okay. So what Zeitwerk does is implements this internally. All right.
Okay. So if we don't have further questions, thank you for the talk.
Excellent. Right. Thank you.